Me and Addison will be showing you guys a Physics 12 concept, which is conservation of momentum in 2 dimensions. Breah and Addison are on the road for the first time. They are out for a girls' trip. They are going 120 kilometers an hour east, consider east the horizontal, in their car that weighs 1,500 kilograms. Owen and Sam are sitting in their 1,300 kilogram car at rest on the side of the highway, trying to find directions to the beach. As Breah and Addison are passing Owen and Sam, they collide. Breah and Addison's car goes 70 degrees north of the horizontal, and Owen and Sam's car goes 48 degrees south of the horizontal. What are both cars' final velocities after the collision? So we will start by drawing a diagram of what the cars were doing before the collision. So here is Breah and Addison's car that weighs 1,500 going in this direction, and we will convert the 120 kilometers an hour to meters per second, which will be 33.33 repeating meters per second, approximately. And then we have Owen and Sam's car, which is 1,300 kilograms and is at rest, which is 0 meters per second. Then we have the diagram after the collision, which is a bit more complicated. So we have Breah and Addison's car, still weighing 1,500. We have V1X here, V1Y here, and then we have V1 prime right here. And this is the 70 degrees north of the horizontal. And then we have Owen and Sam's car, still weighing 1,300. We have V2X here, V2Y right here, and then we have V2 prime labeled right here. And then this is the 48 degrees, which represents the direction in which they went.
Okay, here is the equation we're going to use. We are using this equation because momentum is conserved and is neither created or destroyed, meaning the momentum initial in the x direction will equal the momentum after in the x direction. So now we're going to sub what we know into our equation. So mass 1 is 1,500. V1x is our 33.33. This will be added to nothing on this side because the initial velocity for mass 2 is 0, so that cancels this out. And then, afterwards, after the collision, mass 1 is still 1,500. For V1x prime, we will need to use the cosine ratio because we don't know what that number is yet. So we will use cosine of 70 degrees times V1 prime. And then we will add this to 1,300 times the cosine of negative 48 because we considered east to be the equilibrium, so we will consider south to be in a negative direction. 48 degrees times V2 prime. So now we're going to simplify. So on this side, we will have 50,000. This will be equal to 513.03 V1 prime, because since we don't know V1 prime, we can't sub that for anything yet, plus 869.87 times V2 prime. And that's where we are so far.
Okay, now for the y component. we are going to be using this equation. This is because momentum is conserved. So the initial momentum on the y direction is going to be equal to the final momentum on the y direction. Now, both of these are zero because Breah and Addison's car was moving in the x direction, so therefore they have no initial y component, and Sam and Owen's car was at rest, so they have no initial y component either, making this side equal 0. Now we're going to sub in all of our values, and we're going to use sine. Remember, the 48 degrees is a negative direction. So now we're going to move the negative 966.09 over to the other side.
We are now going to isolate V1 prime. To do that, we just divide both sides. We are now going to use this equation and this equation up here. And to solve for V2 prime, we are going to divide both sides. Which will give us 40.93 meters per second equals V2 prime. Now, to solve for V1 prime, we are going to use this equation here. So V1 prime is 28.05 meters per second and V2 prime is 40.93 meters per second. So that is what each of these values is. So Breah and Addison's car is going 28.05 meters per second after the collision, and Owen and Sam's car is going 40.93 meters per second after the collision.